homework help video, page 288, numbers 5 through 33. Let's go ahead and get started with this assignment right away. Here we go. For numbers 5 and 7, the directions say to find the domain and the range of the relation that is given to you, okay? Well, remember, guys, in every ordered pair, we assume we have an x and a y, okay? So, all of these first numbers in the parentheses would be your x's. Now remember your interchangeable terms. Domain, x value, what are the others? I'm going from memory. Domain, x value, independent variable, and there was another one. But these are your interchangeable terms, okay? So, your domain, I'm just going to put D for domain. Your domain would be 1, comma, negative 2, comma, 0, comma, negative 1, comma, 2. That's all of your x values. So your range would be all of your y values. 5, comma, 8, comma, 4, comma, 5, comma, and then students, I am not going to take off points if you put a 5 twice or an 8 twice, okay? But really, you don't need to. There's no need to. Technically, you really shouldn't, okay? So there we go. There's our domain. There's our range. So pretty simple. Number 7, same thing. Your domain is going to be all of your x values, okay? So here we go. 4, 7, 7 again, 3, and then 4 again if you want to put 4. Okay, there's your domain. Your range would be 1, 2, negative 2, 0, negative 1. So there's your range, okay? Now some books will put your domain or range in ascending order, 3, 4, 7, okay? I do not require that. I'm not sure if this book does or not, but that's not a big deal to me. Okay, so listing out your domain and range. Now, numbers 9 and 10, they want you to sketch a graph of the relationship, okay? So here we go. Let's get our coordinate plane drawn real quick. And now let's list out our ordered pairs. We have 3, comma, 0, input, output. We have, cross that off, negative 3, 0. Cross that off, 0, 9. Notice how I'm looking for all of the inputs. An input is a number that has an arrow coming out. So, this is my input. This came out of it. This is my output. Okay? 4, negative 7. Negative 4, negative 7. So, my x numbers range from negative 4 all the way to positive 3. My y values range from negative 7 all the way to positive 9. So I'm going to have to extend this y-axis a little higher. It looks like, make it a little bigger. There we go. Extend this also a little bit. And here we go. First point, 3, 0. Second point, negative 3, 0. Next point, 0, 9. Next point, 4, negative 7. Negative 7. Next point, negative 4, negative 7. There we go. Now, I'm not sure what the back, I'm going to glance at the back of the book real quick while I'm talking to you guys here. I don't think they wanted you to connect the dots. I would not, because that's really not the idea of the problem. They're just really getting you to understand where these ordered pairs go, okay? But I'm checking now as I'm kind of rambling here. This is number 9. And so let's take a look at number 9 here real quick. has two outputs, so we have 0, comma 2 and 0, comma negative 2. I hope that makes sense, guys. Really not that difficult, okay? And by the way, if you want to skip the step of listing out ordered pairs, feel free to. You're more than welcome to skip that step as a teacher. It's my job to explain the homework in such a way that everyone understands it, so I kind of go a little overboard sometimes with the steps. Alright, but do feel free to skip doing this right here if you want to. Alright, okay, negative 3, 1. Negative 3, negative 1. Negative 4, 0. 0, 2. 0, 2. 0, negative 2. 0, negative 2. Now, just so you know, it's a complete coincidence. Now, these points are lining up like in a little pattern, you know what I mean? A cute little pattern like this. That does not have to happen, okay? You could plot these points and have a point here, 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 and here. It does not matter, okay? So don't think you have to have something like this, okay? So what we're learning here, or reviewing, whatever, is to understand that inputs and outputs are the same thing as ordered pairs, and they can be graphed, okay? Alright, numbers 13 and 15, the directions say use a table to describe the relationship, so we're going to write a table, and we're going to describe the relationship, okay? So it really should be pretty simple to do. We have how many points? 1, 2, 3, 4, 5. So my first point here, now notice guys, these lines are in increments of 2. So this point is where on the x-axis, this point right here is where on the x-axis, negative 4. And it's where on the y-axis, right here, negative 3, that's negative 2, negative 3. So this ordered pair right here is negative 4, negative 3. Alright, let's go to the next ordered pair right here. Okay, where is this? Where is this on the x-axis? Well, it's right at negative 3. That's where it's at on the x-axis, okay? Negative 3. Where is this point at on the y-axis? We'll draw a line over. It's right at 0 on the y-axis. So negative 3, 0. Alright, let's try this ordered pair here. Where is this point right here on the x-axis? We'll go straight down to the x-axis. It's at 0. Where is this point on the y-axis? Well, this is the y-axis, so it's right here at 3. Okay, let's move on to the next point. Where is this point right here on the x-axis? Well, it's right here at 3. Where's that on the y-axis? We'll go straight over to the y-axis. It's at 0. And then lastly, this point right here. Where is this point on the x-axis? 4. Where is it on the y-axis? Negative 3. And there we go. Really not difficult, students. It's really not. Okay. Alright, number 14, same thing. So here we go. 5 ordered pairs again. And let's start with this ordered pair here. This ordered pair right here is where on the x-axis? 0. And where on the y-axis? Well, it's right here on the y-axis, negative 3. Let's go to this ordered pair right here. Where is this ordered pair on the x-axis? Negative 4. And where is this ordered pair on the y-axis? Negative 2. Okay, let's move to this point here. Now this point lies on the x-axis at negative 6. And if you were to draw a line over to the y-axis, it would hit right at 0. So negative 6, 0. Alright, let's take a look at this point here. This point is where on the x-axis? Negative 4. And it's where on the y-axis? Positive 2. The ones that are the toughest, students, are the ones that lie on the x-axis or on the y-axis. So another way to look at this is when it lies on a y or x-axis, say to yourself, how high up or how down low? Well, this number's up 3, that's the y. Where is this point going, left or right? Well, it's right at 0 going left or right. Alright, so there we go. 0, comma 3. Okay? Guys, if you're struggling with this, go back and watch 14 of 13 and 15 again, okay? Get some help on these. Alright, number 17 and 19. They want us to use a mapping diagram to describe the relationship. A mapping diagram. So here we go. Here's my input. Here's my output. Input, output. We have how many points? 1, 2, 3, 4, 5, 6, 7 points. So here we go. This point here is where on the x-axis, -4. That's my input. And the output is my y. My y value is -2. This ordered pair right here is -4 and -2. So there we go. Alright, next ordered pair. Right here. This ordered pair is what? It's -3 on the x-axis. And it's -2 on the y-axis. So my input is -3 and my output is -2. So I can actually draw an arrow to this -2. There's no need to put -2 twice. Next ordered pair here. Well, this is -2 on the x, -2 on the y. So the ordered pair is -2, comma, -2. So my input is -2 and my output is -2. Alright, moving on. This ordered pair is even with where on the x-axis? -2. And where on the y-axis? 3. So -2, 3. Well, guys, I've already got a -2 for my input. So -2, 3. I've got a -2. Put a 3 right here. And then draw an arrow from -2 to 3. Do you see how it's so helpful to write the ordered pair first? Write the ordered pair first. This point right here is even with the x-axis at -1. And it's even with the y-axis at +4. So -1, 4. So your input is -1 and your output is 4. -1, 4. Okay, next ordered pair is right here. Where is that even with on the x-axis? 0. And where does this point lie on the y-axis? Well, 2, 4, 5. So my input is 0, my output is 5. And then lastly, this is even with where on the x-axis? 1. And it's even with where on the y-axis? 6. So my input is 1, my output is 6. There we go, we did it. We took this graph and drew a mapping diagram. Numbers 18. Alright, here we go. Here's my input. Here's my output. And here's my first point. Now this is even with negative. Now look students, this graph is in increments of 1, 1, 2, 1, 2, 3, 4. So okay, so now it's back to normal increments. So it's over. This point is even with -3 on the x-axis. And it's even with -3 on the y-axis. So my input is -3. My output is -3. Alright, next ordered pair that we're going to look at. This ordered pair here is even with -2 and even with -2. So my input's -2. My output's -2. Alright, next. This is even with -1 and even with -1. So my input's -1. My output's -1. Alright, moving on to this point right here. This is 0, 0. So an input of 0 and an output of 0. Alright, moving on. This ordered pair right here is even with 1. And it's even with -1 on the y-axis. So my input is 1 and my output is -1. Okay. Alright, next ordered pair. Right here, it's even with 2 on the x and -2 on the y. as long as you can see where they're going, okay? And then lastly, for our last ordered pair, obviously it's even with 3 on the x-axis, and it's even with negative 3 on the y-axis. So your input is 3, and your output would be negative 3, okay? So guys, there we go. We just drew a mapping diagram, okay? Alright, moving on now. Number 21. This is a really good question. Which of the relations in exercises 13 through 16 are functions, okay? Now watch this carefully. I'm going to help you with something. Anytime you have 2 ordered pairs that are directly, perfectly above and below each other, then your relationship here cannot be a function. Let me show you why, okay? Please watch this carefully. This ordered pair right here is what? 2, 3. Do you see that? Over 2 up 3. This ordered pair directly below it is over 2, negative 3. Do you see that? Do you see that? This point is this. This point is this. Everybody see that? Now, go ahead and do a quick mapping diagram of those 2 ordered pairs, okay? Put a 2 here, and you get out a 3. So your 2 gives you out a 3, but your 2 also gives you out a negative 3, right? 2 gives you out a 3, 2 gives you out negative 3. So this input right here has how many outputs? This input has 2 outputs. Thus, this cannot be a function. So the fast way to check a graph is to see if there are any points directly below, above or below each other. On this graph here in 13, I see no points that are directly above or below each other. So this will be a function. Here, it only has to fail one time. Got it, students? It only has to fail once, and you don't have a function. Well, here it fails 3 times. Here you've got 2 points right above and below each other. Here it happens again, and here it happens again. So this is not a function, no. Here we have a point here and a point here. They're directly above and below each other. It doesn't matter if the point's way up here and the other one's way down here. It doesn't matter if they're a mile apart, if they're above or below each other, directly above or below each other, then you do not have a function. And I proved to you why. Remember, 2, 3, 2, negative 3. This input has 2 different outputs, okay? So no, this is not a function. This one would be yes, because there are no ordered pairs anywhere that are directly above and or below each other. Now, are there some ordered pairs directly across from each other? Yes, but that's totally fine. That's fine. In that situation, this ordered pair is negative 3 and negative 2. And this ordered pair is 3, negative 2. So if you did a mapping diagram of that, you would have inputs of negative 3 and 3 and outputs of negative 2. And that's fine. This negative 3 had 1 output. This 3 had 1 output. That's fine. If your inputs only have 1 output, that's fine, okay? So having said that, yes, this is a function. It's a function because no ordered pairs are directly above or below each other. Alright? Okay, moving on to 23 through, or number 23 and 25. Determine whether the relation is a function, okay? Well, I'm going to do this kind of fast, but here it is right away. Look at this 0. See this 0 here? See this 0 here? Look at that. You have a 0 that has 2 outputs. So right away I know this is not a function. It is not. Do you see how I did that? Now here's the longer way to do it. If you don't have a lot of confidence in this and you want to do it the long way, that's fine. Do a quick mapping diagram. 0, negative 5. 1, 3. 2, 2. 0, 4. So there's your 0. There's your 0. Draw it down to 4, and right away you can see it fails. Negative 5, 6. 3, 4. And there it fails. No, it does not fail again. 3, 4. So it failed one time. This input right here, 0, had two outputs, here and here. Now if you can see that without drawing a mapping diagram, then you're fine. Okay? Alright, number 25. Now, I can tell you right now, this is a function. I can see that right away, okay? Because negative 10 has one output, negative 6 has one output, negative 4 has one output, negative 2 has one output, 2 has one output. Look, and again, don't be embarrassed one bit. If you need to use mapping diagrams to help you, nothing wrong with that, okay? Nothing wrong with that. You can do it quickly, and it probably helps you eliminate little mistakes. Each input has exactly one arrow going away from it, so each input has one output. So yes, it's definitely a function. Yes. Okay. Alright, last section, 27 through 33. These are pretty simple. We're going to evaluate this function at 3. So f of 3 equals 3, negative 9. So f of 3 equals 3 minus 9, negative 6. So there's your answer, negative 6. And don't forget, f of 3 equals negative 6 is the exact same thing as 3 comma negative 6. You put in 3, output, input, and this is your output. Okay, number 29. We're going to substitute negative 2 in. So f of negative 2 equals negative 2 squared, negative 3, and then negative 2 for x, and then positive 2. Well, first we're going to square the negative 2. Negative 2 times negative 2 is 4. Negative 3 times negative 2 is positive 6. Bring down your positive 2. Now combine these and you get 12. So f of negative 2 equals 12. Remember, a lot of students then like to divide both sides by negative 2. And that's obviously wrong. This is not multiplication right here. That's just a notation, okay? F of negative 2 equals 12. So your answer is 12, okay? And don't forget, if I asked you to write that as an ordered pair, you would write it like this. Input, output. Alright, number 31. We're going to evaluate the function at f of 1. So f of 1 equals 1 half, 1 squared, negative 4, 1. First of all, you square the 1, okay? So now we have 1 half times 1, because 1 times 1 is 1. 1 half times 1 is 1 half. Negative 4 times 1 is negative 4. Combine those and you will get a negative 3.5. Okay, so f of 1 equals negative 3.5. They probably have negative 7 over 2. No, they don't, okay? Negative 3.5. This is your input. This was your output. You put in a number into the function and you got out negative 3.5. You could also write it like this. 1 comma negative 3.5. Okay? Lastly, we're going to evaluate this function at 1 half, f of 1 half. So f of 1 half equals 1 half squared, negative 2 times 1 half, negative 4. Okay? Well, first of all, we're going to square 1 half. That would give you 1/4. Then negative 2 times 1 half is negative 1, negative 4. Okay? Well, we have a positive 1/4 and a negative 5, a negative 1. You owe me 1, you owe me 4, negative 5. And then negative 5 and 1/4 would be a negative 4 3/4. I think I did all this right. I hope that I did. And yes, we did. So f of 1 half equals negative 4 3/4. Now if I asked you to write that as an ordered pair, you have an input of 1/2 and an output of -4 3/4 input, output. Okay? Guys, I hope this homework help video has been relatively simple for you, but I hope it's also been a help to you. If you have any questions, don't hesitate